Tonight, I want you to forget everything you think you know about gravity. Forget the word itself for a moment. Forget school equations, falling apples, and textbook diagrams. Instead, imagine waking up tomorrow morning in a universe where gravity suddenly disappears. The oceans would rise into the sky. The atmosphere would drift away into space. The Earth itself would break apart piece by piece while the moon escaped into darkness. Every star in the universe would slowly unravel. Galaxies would dissolve. Life would become impossible in seconds. And yet, despite gravity controlling almost every large structure in existence, science still cannot fully answer one terrifying question. Why does gravity exist at all? Not how it works, not how to calculate it. We can already do that with extraordinary precision. We can send spacecraft across billions of kilometers using the mathematics of gravity. We can predict eclipses centuries before they happen. We can even detect ripples in spacetime from black holes colliding across the universe. But the deeper question remains unanswered. What is gravity really? Why should matter attract matter? Why does space bend? Why does time slow down near massive objects? And how can an invisible force shape the destiny of stars, galaxies, and even time itself? The more scientists investigate gravity, the stranger reality becomes. Empty space is not truly empty. Time is not constant. Black holes can trap light itself. And the very force holding you to your chair right now may be connected to secrets hidden deep inside the structure of the universe. By the end of this video, you will realize that gravity is not just a force pulling things downward. It may be one of the greatest mysteries ever discovered. A mystery so deep that even modern physics still stands at the edge of it, searching in the dark for answers. Gravity is so familiar that most people never stop to question it. Every moment of your life is controlled by gravity. You wake up because gravity holds you to the earth. The oceans move because of gravity. The moon circles Earth because of gravity. Entire galaxies spin under its influence. Yet, despite how common it is, gravity may be the strangest thing in the universe. The mystery begins with a simple observation. Objects fall, a stone drops from your hand, rain falls from the clouds, an apple falls from a tree. At first glance, this seems obvious, but science becomes powerful when it refuses to accept obvious things without explanation. Why should objects move downward at all? What determines down? Why does the earth pull on objects instead of pushing them away? For a long time, people believed heavy things naturally wanted to move downward. It sounded logical because it matched everyday experience. But careful experiments revealed something astonishing. If air resistance is removed, all objects fall at the same rate regardless of weight. A hammer and a feather dropped in a vacuum land together. This discovery changes everything because it means gravity is not simply about heaviness. The Earth treats all masses equally. A giant boulder and a grain of sand respond to gravity in exactly the same way. Then comes an even more surprising realization. The force that makes objects fall on Earth is the same force controlling the motion of the planets. The moon does not float magically in space. It is constantly falling toward Earth. The reason it never crashes is because it also moves sideways extremely fast. Imagine throwing a ball. Throw it harder, and it travels farther before hitting the ground. Throw it fast enough, and it curves around the Earth forever. That endless fall is called orbit. This idea connected the heavens and the Earth into one single system. Before that, people thought the sky obeyed different rules from the world below, but gravity united them. The same invisible influence guiding falling apples also controlled stars, moons, and galaxies. Suddenly, the universe became understandable through universal laws instead of separate mystical realms. But the deeper scientists looked, the stranger gravity became. Every object with mass attracts every other object in the universe. Right now, your body is pulling on distant stars, and those stars are pulling on you. The force is tiny because of the enormous distances involved, but it exists. Gravity is universal. It never turns off. It acts across unimaginable distances. And here is where the mystery becomes uncomfortable. How exactly do objects influence each other through empty space? Imagine the sun pulling Earth across millions of kilometers of nothingness. What carries that pull? Is there some invisible thread connecting them? For centuries, scientists could describe gravity mathematically with incredible precision, but nobody could explain what gravity actually was. The equations worked beautifully, but the deeper reason behind them remained hidden. Then physics experienced a revolution that completely transformed our understanding of reality. Gravity was no longer seen simply as a force. Instead, massive objects were understood to bend space and time themselves. This idea is difficult to imagine because humans do not naturally think of space as something flexible. We imagine space as emptiness, like a giant container holding objects. But according to modern physics, space is dynamic. It can stretch, curve, and distort. A useful analogy is a stretched rubber sheet. If you place a heavy bowling ball in the center, the sheet bends downward. Smaller balls rolling nearby curve toward the bowling ball, not because the bowling ball reaches out and grabs them, but because the surface itself is curved. In a similar way, planets move around stars because stars warp the geometry of space-time. Objects simply follow the curves. That means gravity is not just a mysterious pull. It is the shape of reality itself. The Earth moves around the Sun because the Sun bends space-time around it. The Moon moves around Earth because Earth bends space-time too. Everything in the cosmos follows invisible curves created by mass and energy, but this explanation raises even deeper questions. What exactly is space-time? How can empty space bend? How can time itself be affected? These questions push human imagination to its limits because they challenge ordinary experience. Yet experiments confirm these bizarre effects again and again. One of the strangest discoveries is that gravity affects time. Near strong gravitational fields, time moves more slowly. Clocks near massive objects tick slower compared to clocks farther away. This is not an illusion or a trick of measurement. Time itself changes speed. Even on Earth, time passes slightly slower at sea level than on mountaintops because gravity is stronger closer to Earth's center. This effect becomes extreme near black holes. A black hole forms when enormous amounts of matter collapse into a tiny region of space. Gravity becomes so intense that escape becomes impossible. Not even light can escape. Around a black hole, space and time become warped almost beyond comprehension. If you could watch someone falling toward a black hole, time for them would appear to slow dramatically from your perspective. Black holes reveal how little we truly understand gravity. At their centers lies a singularity, a place where our current laws of physics break down completely. The equations produce infinities, which usually means the theory is incomplete. Nature is telling us there is something deeper we do not yet understand. This becomes even more mysterious when gravity meets quantum mechanics. Quantum physics describes the microscopic world of atoms and particles with extraordinary accuracy. It explains electromagnetism and nuclear forces in incredible detail. But gravity refuses to fit neatly into the quantum framework. The mathematics becomes chaotic, the smooth curves of space-time conflict with the probabilistic nature of quantum reality. This is one of the greatest unsolved problems in science. Physicists have spent decades searching for a theory that unites gravity with quantum mechanics. Some believe gravity is carried by tiny particles called gravitons. Others think space-time itself emerges from more fundamental quantum information. Some theories suggest hidden dimensions beyond the ones we experience. Others propose that gravity is not fundamental at all, but an emergent effect produced by deeper laws. The remarkable thing is that humanity has reached a point where we can predict eclipses centuries in advance, detect gravitational waves from colliding black holes, and map galaxies billions of light years away, yet we still do not fully know why gravity exists at all. We understand its behavior with astonishing precision, but its ultimate nature remains hidden. Gravity also shapes the entire history of the cosmos. Without gravity, stars would never form. Clouds of gas in space would never collapse together. Nuclear fusion would never ignite. There would be no sunlight, no planets, no chemistry for life. Galaxies would never emerge. The universe would remain a thin, cold fog of particles drifting endlessly apart. Gravity is the architect of cosmic structure. It gathers matter together and creates complexity. Every star in the night sky exists because gravity slowly pulled gas inward over millions of years. Every planet exists because gravity collected dust into worlds. Even your own body exists because gravity forged the stars that created the elements inside your atoms. The calcium in your bones, the iron in your blood, the oxygen you breathe, were all produced in stars shaped by gravity. And perhaps the strangest part of all is that this invisible phenomenon, which nobody has ever directly seen, governs reality on every scale. From falling raindrops to colliding galaxies, gravity silently controls the universe while hiding its deepest secret from us. In the end, gravity is far more than a force that pulls objects downward. It is the invisible architect of reality itself. It shapes stars, builds galaxies, controls the motion of planets, bends light, slows time, and holds the universe together with silent precision. Yet, after centuries of discovery, humanity still stands before one profound mystery. We know how gravity behaves, but we still do not fully understand why it exists at all. And perhaps that is the most beautiful part of science. The universe still contains mysteries greater than our imagination. Every falling raindrop, every orbiting planet, every distant black hole is a reminder that reality is far stranger and more magnificent than it first appears. The deeper we explore, the more we realize that knowledge is not the end of wonder, it is the beginning of it. Maybe one day humanity will finally uncover the true nature of gravity. Maybe future generations will discover answers hidden beyond space, time, and quantum reality itself. But until then, gravity remains one of the greatest unanswered questions ever asked. A silent force guiding the cosmos while keeping its deepest secret hidden in the fabric of existence. Thank you for joining me on this journey into one of the universe's greatest mysteries. I hope this exploration inspired you to look at the world differently, to question ordinary things more deeply, and to never lose your curiosity about the universe around you. Good luck on your own journey of discovery. Keep asking impossible questions and never stop wondering about the mysteries that hold the stars together.